Exam 3, problem number 10. Let the joint density function of x and y be given by this equation. What is the probability that x is less than 2y? Here we're asked to find the probability that x is less than 2y in number 10. And here's the region. X and y are from 0 to 1, and that's the line of x equal to 2y, and we want to be x less than or equal to y, so that's the shaded area. So then if we integrate the function over this region to find the probability, y goes from 1 to x over 2, and then x goes from 0 to 1. So here's the region. So you integrate, well, we're integrating with respect to y first. And we're doing that, if you integrate with respect to x first, then you have to go from this function 2y to 0. But then at this point, you have to go from a different set of values. So it's easier to integrate y first. So you integrate y, plug in the values, combine, integrate x, simplify. Answer is 19 over 24. Number 11. An urn contains 6 red balls and 3 blue balls. One ball is selected at random and is replaced by a ball of the other color. A second ball is then chosen. What is the conditional probability that the first ball selected is red, given that the second ball was red? Problem number 11 is a ball is selected at random and then is replaced by a ball of the other color. Then the second ball is chosen. What's the conditional probability that the first ball selected is red, given that the second ball was red? Okay, so if we let x1 be the color of the first ball that's drawn, and then x2 be the color of the second ball that is drawn, then let's find this probability first. The probability that the second one is red. Well, if we add in a variable and probability that x2 is red and x1 is red or blue, so this event here is 1, so we're not changing the probabilities. But then we can condition on, we can do something with that. This equals this. The probability that x2 is red and x1 is blue plus x2 is red, x1 is red. So then this piece can be written as a conditional, which is this one. The probability that x1 is blue times probability that x2 is red given that x1 is blue. And then this one too. Probability that x1 is red times probability x2 is red given x1 is red. Well, once we know this, what we did on the first ball, then we can calculate probabilities on the second ball. So the probability that we draw blue is 3/9, and then probability we draw red, given that the first one was blue, was 7/9. This one, the probability that we draw red is 6/9. Probability that we draw red, given the first one was red, is 5/9. That reduces to this. So now the question of interest is the probability that the first ball is red, given that the second ball is red. So this conditional can be written as this: the probability that x1 is red and x2 is red over the probability that x2 is red. Well, this numerator can be rewritten as a conditional. So the probability that x1 is red times probability that x2 is red, condition on x1 is red. Well, this piece here, the numerator, is this piece right here, which we said was this. So this numerator is here, and the probability that x2 is red we just calculated, so that's 51 over 81, which reduces to 30 over 51, which reduces to 10 over 17. Number 12. Let x and y have the joint density function of 2 x between 0 and 1, y between 0, x and 1. What is the marginal density of x? On problem number 12, we have a joint density that is equal to 2. What's the marginal density? Well, drawing a picture of the region, we know that x goes from 0 to 1, but y goes from x to 1. And so this is the region here. So to integrate, or to find the marginal density, we have to integrate out y from the joint density. And y goes from x to 1. X to 1. Integrate 2y, plug in the values, we get 2 times 1 minus x. Number 13, let x be a random variable having continuous cumulative function, capital F of x. What is the cumulative distribution function of y, which is equal to the max of 0 and minus x? So number 13, we're giving that x is a continuous distribution, and what's the cumulative distribution of y equal to max of 0 and negative 1. So this one is a little bit tricky. If this is x, and if we think about it, that if x is positive, so x is strictly positive, y is always 0. So this whole region goes to this point. So the probability that y is 0 is the probability that x is greater than 0. Well, that's 1 minus the cumulative distribution function, which is 1 minus f of 0. Here, if x is, I say, is 0 or negative, then y is equal to minus x, so which is positive, because x is negative. So if we take the negative of a negative, it's positive. So from 0 on, those are all mapped to positive y. Okay, so the first note is that y can never be negative. So the probability that y is negative is 0. Okay, so now let's pick a value here and look at the cumulative distribution function of y. So y is less than or equal to little y. But in all cases, that y is minus x. So minus x is less than y. So if we take the negative to the other side, then we have to change the inequality. And then this is the same as 1 minus x being less than or equal to y. So now this equal sign, I can keep the equal sign because x is continuous. So the probability of a single event is 0. So that really doesn't play a part. And then this right here is just 1 minus f of minus y. So the answer is E. Number 14. Suppose that the joint density function of x and y is uniform over the region x plus y less than 2. What is the probability that exactly one of the two events, A equals x is less than 1 and B equals y greater than 1, occurs? So problem 14, we want to find the probability that exactly one of the two events occurs. So event A is less than 1, x is less than 1, and B is y is greater than 1. Okay, so first of all, we're given a region that x plus y is less than 2 for x positive and y positive. So if this is the x and this is y, our total region is here. So we have to, so A is the probability that we're less than y, which is this total region here. And B is that we're greater than 1, which is just this little triangle here. Well, if we're in this top region, then we're actually satisfying both events, and we don't want that. We want one of those and not the other. So we're asked to find what's probability of A and not B, plus the probability of not in A and B. So this one here comes down to probability A is X is less than 1, and here the complement is Y is less than or equal to 1. So that's this area here, plus X, A complement is X is greater than 1 and Y is greater than 1. Well, we can't, that's these regions here, and we can't be in both at the same time. So so this is 0. Well, here is the area of a square, and we know the height, or the joint is 1/2. So the area of this region times the height, or the volume, is going to be 1 times 1 times 1/2. So the answer is 1/2. Number 15. A fair coin is tossed 100 independent times. The probability that the number of heads and the number of tails differ by exactly 2 is approximately equal to. So number 15, we want to find the probability that we're exactly, they differ by exactly 2. So if we let X be the number of heads, then, and we're flipping a coin 100 times independently. So X follows a binomial. So to be off by exactly 2, that means X is 49. So number of heads is 49 and number of tails is 51. Or we could have the number of heads is 51, number of tails is 49. So the probability of each of those events is this. Okay. So one note, see, since it's 1/2, we're actually symmetric about X equal 50. So this piece here is just 1/2 raised to the 100, and this is 1/2 raised to the 100. And this combination is 100 choose 51 is the same as 100 choose 49. So really this is, those can be combined into 2 times this. So 100 choose 49, 1/2 to the 100 equal 2. So that is 2 times X equals 49. Well, this is actually going to be pretty tough to calculate. I mean, because 100 factorial, that's a big, big number. So we need to use the normal approximation to this. I write it down, but note that I have these. Anyway, let me show you this. So here, if this is a normal distribution and we want to find the probability that X is 49, so this there, so we have to add continuity corrections of 1/2 to both sides, and then to find the area under this normal we have to transform it to the Z curve. So 49.5 minus 50 divided by the standard deviation of 5 goes to here, which is minus 0.1, and this point here goes down to negative 0.3. So 48.5 minus 50 divided by 5. Now if we look in a Z curve, mine is a cumulative, so it is the probability we're less than minus 0.1, and then subtract off this probability, which is 0.0781. So that's the probability that X is 49. So if you plug in that here, then it's approximately equal to 1562, which then rounding to match the answer given is 0.16. Number 16. If the variance of X plus Y is 3 and the variance of X minus Y is 1, expected value of x is 1, and the expected value of y is 2, then what is the expected value of x times y? So number 16 is we're given that the variance x plus y is 13. But remember that this variance is variance of x plus variance of y plus 2 times the covariance. And the difference, it was given to 1, but that's also variance of x plus variance of y minus 2 times the covariance of x. And the minus comes from here. So if we subtract these two equations, this equation minus this equation, these pieces drop out and we're left with 4 times the covariance of x equal to 2. Well, this implies the covariance of xy is 1/2. So now the formula that covariance of xy, we know it's 1/2, that's equal to the expected value of x times y minus these the means, expected value x, expected value y, which we're given as 1 and 2. So the only piece that's unknown is this, so we can solve, and expected value of x times y is 5/2. Number 17, a fair coin is tossed n times, where n is an even integer. What is the probability that the number of heads exceeds the number of tails? So here, we're tossed a fair coin n times, where n is even. What's the probability that a number of heads exceeds the number of tails? So x is binomial with n and 1/2. Now n is even. So when n is even, there's a middle value. And that middle value is n/2. Now if n were odd, then there is not one value that's in the middle. It's kind of the difference between two. So that's why they say it's even. So the probability that the number of heads exceeds the number of tails is x has to be greater than n/2. Well, to be strictly greater than n/2, that means we have to add 1. So x is greater than or equal to n/2 plus 1. But one note is that the whole region has to add to 1. So the probability that x is less than n/2 minus 1, plus probability that it's equal to n2, plus probability that x is greater than n or equal to n plus 2 plus 1, that has to be 1. And since that x is 1/2, we're symmetric about n/2. So this probability is actually equal to this probability. So we can combine those into this 2 times. Well, here, since it's for a single value, with that we can plug that in potentially. So if we subtract this to the other side, we get, and remember there's a 2 there, so we're also going to have to divide that over. That's what this 1/2 is. So it's 1 minus this value, and then divide or times 1/2. But the probability that x is equal to n/2 is n choose n/2 and then 1/2 to the n. Well, if you multiply this 1/2 in, 1/2 times 1 is this, and then n choose n/2 comes down, but then we add a 1/2 to this, so we get n plus 1. So that's the answer. Number 18, suppose that x is a random variable with moment generating function equal to this equation. What is the probability x equal to? Number 18, we're given this moment generating function here. No, here. But the definition of moment generating function is the expected value of e t to the x. It's a Laplace transform. So that means we take e to the t x, or in this case we're going to say j because that's the dummy variable that's used to sum, times the probability of j. So this is the definition of expected value. So if we're given that the function equals this, let's, and there's a tj and there's a tj, so let's kind of rewrite this as take one of those e's out, so we get the expected value of tj, that's this piece, times e to the minus 1 times j. So this piece here is the function that for the random variable. So the f of x is equal to 1 over e to the x factorial. And then we want to know the probability that x is equal to 2, so that's f of 2. We'll plug in 2 to our equation and you get 1 over e to the 2 factorial.